For the longest time, we've had AI that can chat with us, write an essay, even answer trivia questions. But the real promise, the thing we've all been waiting for, is an AI that can actually do stuff for us. Handle complex, multi-step tasks. Well, today, we're going to dive into how researchers are finally putting these models to the test to see which ones can move beyond just talking and actually start doing.
So let's just ask the big question right up front. Can an AI really be your assistant? We've all been promised this future, right? A true digital helper that can take real work off our plates. But when you ask it to do something genuinely useful, can it deliver? It seems like a simple question, but the answer, well, it's surprisingly complicated.
And this, right here, this illustrates the problem perfectly. Sure, an AI can tell you the capital of Nebraska in a split second, but what about a real-world request like this one? Take a video, change its style, dub it into another language, and then post it to TikTok. That's not just one command, that's a whole project. And this is exactly where most AIs today completely fall apart.
So if we want AIs that can actually handle these kinds of complex jobs, we have to completely change how we test them. The old benchmarks, they were basically like a trivia night. They just tested what the AI knew. But what we really need is something more like a decathlon, a series of events that test practical, multi-part skills.
And this chart really nails the key difference. See this column right here? Models tool dependencies. For all the older benchmarks, the answer is a big no. They tested tools one by one, in a vacuum. They had no way of knowing if an AI understood that the output from step 1 becomes the input for step 2. And that, right there, is the critical gap that this new benchmark, TaskBench, was built to fill.
So how does TaskBench pull this off? It's all built around a concept called a tool graph. Think of it as the official course map for our AI decathlon. It doesn't just list all the possible tools. It actually maps out how they all connect, showing the exact sequence you'd need for a real-world project. It's like a blueprint for getting things done.
And with that, let's get into the main event, the AI Decathlon, powered by the incredible TaskBench framework.
So how in the world do you create thousands of realistic, complex challenges for these AIs? The researchers use this really clever method they call back-instruct. Instead of starting with a user's question, they started with the answer. First, they built that giant tool graph, then they picked a complex path through it. And finally, this is the brilliant part, they had another AI look at that solution path and work backward to create a natural-sounding user request that would require it. It's kind of like writing the answer key first and then designing the perfect test question to match. And here's what that whole process looks like laid out in one elegant pipeline. This is the engine that allowed the researchers to generate thousands upon thousands of tough but fair real-world tests for every AI competitor. Okay, so we have the competition and we have the challenges. But what are the AIs actually being judged on? It turns out every single task in this decathlon is scored across 3 absolutely critical events. The first event is all about planning. It's called task decomposition. Basically, can the AI even understand the user's end goal and break it down into a logical step-by-step to-do list? Because, let's be honest, if you can't even make a coherent plan, you have zero chance of actually succeeding. The second event is tool selection. Okay, you've got a plan. Now, can the AI pick the right tool for each step? Which tool do you use for captioning? Which one for audio editing? And most importantly, does it know the right order? This is where understanding that tool graph we talked about becomes absolutely essential.
And the third and final event is parameter prediction. This is all about the execution. It's not enough to just pick the video editor tool. The AI has to know exactly how to use it. Which file is the input? What style should be applied? What should the output file be named? This is where the rubber meets the road, because just one wrong setting can cause the entire project to fail.
So, we have the course, we have the events, and the AI decathlon is officially complete. Now for the moment we have all been waiting for. Which of these AI athletes actually came out on top? All right, the competition was fierce, no doubt about it. After running these models through such a demanding gauntlet, who actually stood on the winner's podium at the end of the day? Let's start with tool selection, just picking the right tools for the job. And wow, looking at the results for these multimedia tasks, we see a pretty clear winner. GPT-4 is way out in front, scoring almost 91%. Gemini Pro puts in a very solid performance at over 81%, but you can already see a noticeable gap.
And then models like CodeLlama are quite a bit further behind, which just goes to show how tough this really is.
But here's a fascinating little nugget from the paper. The researchers found that pretty much all the models were much better at picking the right tools, the nodes in the graph, than they were at figuring out the connections between them, the edges. In other words, knowing what ingredients you need is way easier than knowing the right order to mix them in.
And that difficulty with figuring out the right order, well, it becomes a massive chasm when we get to actually using the tools correctly. GPT-4's accuracy drops, but it's still at a pretty solid 72%. But just look at the other models. The scores absolutely plummet. This proves it's one thing to know you need a hammer, but it is a whole other thing to know which nail to hit and how to swing it.
So, after all of that, what's the big takeaway from our AI decathlon? What does all this really mean for the future of AI assistants that can actually, do things for us?
Well, the paper's analysis suggests it really boils down to three key things that separate the winners from everybody else. First, just fundamental reasoning ability is still king. Second, models that were pre-trained on computer code do a lot better. And that makes total sense, right? Code is all about structured logic and dependencies, which is exactly what this kind of task requires. And third, it looks like models that are fine-tuned with human feedback develop more generalized problem-solving skills, which makes them way more adaptable.
And this all brings us right back to where we started. You see, the most important result from all this research isn't just a leaderboard of which model is best today. It's the benchmark itself. For the very first time, we have a serious, standardized way to measure an AI's ability to perform these complex, real-world tasks. So I'll leave you with this thought. Now that we can finally measure it, how long do you think it'll be until an AI can manage an entire project for you from start to finish?